Hello, welcome back to my channel. So this is part 2 of mole conversion, specifically using two-step. And this is when we're converting from particles to grams or grams to particles. And grams meaning like mass, so they are the same thing. Okay, so I've also, here are 2 questions that we'll work on together. And then I've also included the conversion factors that you'll use. So in the previous video with part 1, we got to use only one of the 2. Whether I'm finding particles or given particles, I use Avogadro. Whether I'm given grams or wanting to find grams, I use this conversion factor. But this time we're going to use both. It's a matter of which order. So for this example, how many particles are in 5.5 grams of H2O? We're trying to find particles, and we're starting off with grams. So notice how there's direct conversions between mole to gram, vice versa, and then mole to particle and vice versa. There's no direct conversion factor between gram to particle and the other way around. So that's why we have to go through the mole first. That is our first step. So again, these are 2-step conversions. The first step will be converting to moles. The second step is to convert to what we want. So we are starting off with 5.5 grams H2O over 1. Again, the strategy or the method for dimensional analysis still stays the same. We have grams of H2O. Pull down that unit diagonally to cancel that out, grams of H2O. And then we are going to mole first. So mole H2O goes on top. So these two are the conversion factors, and according here, we have 1 mole per molar mass. So I have 1 mole of H2O, and then find the molar mass of H2O, again, from the periodic table. So the molar mass for water is 18.015. So that is the first step. We are in the middle. Now the second step is to actually now convert to particles, and that's when we use this conversion factor. So again, same thing, mole H2O, pull that down here. And then particles go up here. And it's 1 mole, and then we always use this Avogadro's number, 6.02 times 10 to the power of 23. So when you plug this in, again, it's a giant fraction. What I would do is just multiply the top across. Whatever number you get, you divide by the bottom. So when I plug this in, 5.5 times 6.02 E23, you get a number. That is your numerator. And then I'm going to divide that by 18.015. So I should get this number. I'm going to do 1.84 times 10 to the power of 23. And it is particles H2O. That is the final answer for this 2-step conversion. Okay, so how about the other way around? What if I am starting off with particles and I'm trying to find grams? It's literally opposite, okay? But the common mistake that I see, like, you know that it's opposite, but then you immediately start off with the Avogadro's number. That is not correct. You always start with the number that you're given in the question. So 6.37 times 10 to the power of 17 particles H2O over 1 times, again, pull that unit diagonally, and that is when you use the Avogadro's number to get to moles. First step is always moles. Alright, so that took care of that. We're halfway there, or almost there, actually. And then the next and last step, we pulled that mole here, mole of H2O, and then we're looking for grams of H2O. So we already got the mass from up here, 18.015 grams per 1 mole. So that is a setup for particles to grams, or particles to mass. And as a calculator use, same thing. You plug in the top, multiply, and then divide by the bottom. So to do that, I got 6.37 E17 times 18.015. You get a number. Divide that by your 6.02 E 23. So that's my final answer. I'm going to do it in hundreds place. 1.91 times 10 to the power of -5 grams of water. So that is a very small amount. Very, very small amount. But that is our final answer there. So here are two other examples that I will have you try by yourself. Same method, but you're going to try this on your own. This is from particles to grams, and this is grams to particles. So pause the video, do the work by yourself, and then unpause to check your work for the final answer. Okay, so this is your final answers for these problems. The first one is 6.08 times 10 to the power of 10 grams of CO2. That is a lot, because if you think about it, this is a lot of particles of carbon dioxide, and that leaves you with a lot of grams. And then same thing here, other way around, you end up with 1.82 times 10 to the power of 23 particles of CO2. So that wraps up the two-step mole conversions, doing two ways. So I hope this helped, and have a great day. Thank you for watching.